In this video, we are going to use the Euclidean algorithm method to calculate the greatest common divisor of two integers a and b, that is the GCD of the integers a and b. Euclid's algorithm is a method for efficiently finding the GCD of two numbers, say a and b. It is one of the oldest algorithms in common use, and also it appears in Euclid's Elements, which he wrote in 300 BC. The GCD of two numbers a and b is the largest integer that divides both a and b without leaving any remainder. This GCD, the greatest common divisor, is also known as the greatest common factor GCF, highest common factor HCF, highest common divisor HCD, and GCM. There are various applications of this Euclidean algorithm. This can be effectively used to solve these following problems. Problems in simplifying any fractions, finding the coprimes. The Euclidean algorithms are used to find the prime factors of a number. They are used in changing the numerical range of data that is scaling in computer techniques, and also in cryptography. In the computer world, this Euclidean algorithm is used in arithmetic scaling for this RSA crypto system. Let us try to find the GCD of the two numbers 741 and 285 using Euclid's algorithm. Now here we have 741 can be expressed as 285 285 plus a remainder of 171, and then 285 can be written in terms of 171 as 171 plus a remainder 114. 171 is 114 50 plus 57 remainder, and then 114 is 257 with no remainder 0. This 57 will be the GCD for the two numbers 741 and 285. So this is the method of Euclidean algorithms. That is, you can consecutively divide these numbers. See, suppose if I'm trying to find the GCD for 40 and 24 using Euclidean algorithm, we can also divide by usual division. 24, when we divide 40 by 24, it is 124, and the remainder is again 16. Then we can divide 16, 24 can be divided by 16, and that is 116, and the remainder is 8. Again, we can divide that 16 by 8, and the remainder is 0. And that last number, 8, will be the GCD. So the whole thing what we got using the Euclidean algorithm can also be explained step by step like this. The GCD of 285 and 741 is nothing but the GCD of 741 and 285, and which is the same as GCD of 285 and 171, because 171 was our remainder. And again, we find the GCD of that 171 and the remainder what we get. Again, 114 and the remainder, and 57 and the remainder was 0. So that 57 happens to be the GCD of the two numbers. In computer science, pseudocode is an informal, high-level description of operating principle of a computer program or other algorithm. Pseudocode typically omits details that are essential for machine understanding of the algorithm, such as variable, declarations, systems, specific code, and subroutines. Many programs use pseudocode to plan at the function of an algorithm before setting themselves to move technical task of coding. So in a pseudocode, this will be an application of GCD of the two numbers A and B. Or they may also prepare a flow chart before finding the GCD of the two numbers. The flow chart may look like this. Or when they want to implement this in computer languages like Python, C, C++, Java, C#, etc., they can also use some coding and get the Euclidean algorithm. And this is an example of Python application of Euclidean algorithm. So in computer world, the knowledge of GCD is essential. And when you want to go to coding theory, the topic GCD plays the main role. That is the basis for all the computer applications coding theory. So hope this video was helpful in understanding how we find the GCD using Euclid's algorithm. Because Euclid's algorithm will be helpful when we are trying to find the GCD of large numbers, maybe 6 digits or 7 digits, or when we are trying to use computer applications to find the GCD, the Euclidean algorithm plays the main role. Thank you for watching this video, and thank you for all the supporters of such videos. And thank you for listening.